Hey guys, I just wanted to make a quick video here for anyone that's doing the FastAI 2022 course in 2025. It's just a few small things have changed, as well as people who want to do inference with their model just on a Windows computer, regular Python environment. I'm mainly going to cover some stuff from lessons 1 and 2 and just a tiny bit of lesson 3, as well as the stuff that's in the first section of the book. But it'll mostly be focused on the stuff in the first two videos. I'm also pretty new to deep learning, so some of the stuff in here may not be the best practice, but I just wanted to share what worked with me, since I found a few things that could be frustrating for people who maybe don't have experience with programming. Okay, so let's get right into it. So I think the first thing that you should do to make this project go well is to spend some time kind of picking your problem to solve if you haven't already. Since we're going to be using DuckDuckGo to create our data set, I think a great spot to start playing around is just in the search engine, searching for images, and seeing what kind of results you're going to get back and whether or not that's going to make a good data set for you. So what I chose was to identify some propaganda posters by the country that they were designed for. But to pick a good problem, the things that I would rules I would stick to is to pick something that you can classify on your own in a way. So when you're looking at these pictures that you can tell, in this case, which country they came from on your own. For example, I tried to make a cloud identifier, and it didn't go super well for me because I can't actually identify clouds that well. The second thing is I would just make sure you're kind of getting consistent output here in the search results, right? Like here we've searched for American propaganda posters, but with only like a slightly different search, USA propaganda posters, where you're starting to get stuff that's like on walls, stuff here. This is like a Korean one anyways, and I don't know how this made it to being in the top of the search results. But just some slight rewording can make a big difference. So this search here is a little better. We're getting, really consistent results, stuff that's not on walls, good up close images of the graphics and stuff. And then one other thing to keep an eye out for is if your search results are super heavy with watermarks that are going across the image, that can create basically the model might learn features that aren't actually something we want it to learn. Learn to identify the watermarks instead of the actual content of the image. So yeah, those are just my guidelines on how you can pick a good project for this exercise. Alright, so let's go over to the notebook. And we'll get into it. I'm going to cover kind of a lot of stuff since it's sort of the whole first section, but I'll stay focused mostly on just the stuff that's different from the original videos. So here I've just left the initial code that it starts you with in Kaggle. Here is my install of FastAI. And again, none of this is necessarily the best way to do it, but by adding these two, I've cut down on a lot of these incompatibility errors that are showing up, and it seems to have resolved enough that I get good results here. Bring FastAI in as normal, and then we're going to install DuckDuckGo Search, which has slightly different package name now. We'll then import that, and we'll just try giving it a search for images with this query Russian propaganda poster, and we can see here it returns back a URL and some other image information. And then instead of using the Fastbook method for downloading the image, we're gonna go ahead and just use our own. And so I've made one here that's pretty simple. just uses that same function that we just did to search, and then zips all the item together with a with the image, just with the URL, I believe. Yep. So it's going to come back with just a list of the URLs. We'll take a look at that first one. So then here's an example here of downloading the URL and then opening it, and then some kind of compressed syntax for just doing the same thing here. And we'll use these pictures later just to play around with our model after we've trained it. Okay, and then here's the section where we're going to go ahead and download all of the images that we'll use to create our data set. So what I have is American, Chinese, Russian, Indian, North Korean, Irish, and Japanese. And then it's going to go ahead and create those folders and put 100 or so images from each one together. And I picked these a little bit strategically, trying to kind of choose countries that it's not going to get confused super easily. For example, like lots of similar character sets, like if North Korean and South Korean, it can kind of get confused, even though they have very different ideologies, and even their posters might be different. It still gets tripped up a bit. American and England it has some confusion with, and even still, we'll see it has some issues here for sure, but it's able to identify fairly consistently. So we'll go ahead and delete all the bad downloads here. And then this is about where lesson 1's going to stop after, but we're going to train the initial model just to help us after, and then we're going to go ahead and clean the data up, which is why it helps a lot to actually understand the problem at least a little bit that you're solving here. So we'll create our data block just as normal. And everything's looking pretty okay here. These do look like they belong to the country that they come from. We'll go ahead and train a model. And with ResNet34, I can only get to about 0.46 error rate with the data as it is currently. And we'll go ahead and try and run a classification. We can see that if we try and put our China picture in that we downloaded earlier, it identifies it as North Korean pretty confidently, which is not great. So we've got some more work to do. And we're going to go ahead and use that learner that we just made to diagnose where the model is struggling and see where it's performing well and poorly. So taking a look at the confusion matrix here, on first glance what we want to see is just kind of this diagonal dark line here is the ideal, right? And anything that's kind of diverging from that is issues that we kind of need to look into. So we can see here that the Chinese ones, it's identifying really well. It's also identifying American and Russian fairly well, and North Korean not too badly as well. But the Indian, Irish, and Japanese are all it's not doing quite as well on. We can see it's making a lot of American predictions that aren't American, as well as predicting a lot of Japanese ones that are actually American. So we'll take a deeper look into some of those problems. And then right here, we'll take a look at some of our data items that are that had the highest loss during training, and see if we can understand why. Yeah, there it is. There's one of the biggest problems that I've found with trying to create the data set this way, which is like a clash between Japanese and American that it seems to be having pretty consistently. So it's guessing that this is Japanese somehow when it's an American. We can see it clearly is an American piece of propaganda. It's in English and has like racist depiction of Japanese person and a little bit of a slur there too. I mean, in a way, it almost makes the model look a bit racist, but we'll see that's not actually the case. Um, Here we have one where it guessed American and it was North Korean. So that does seem to be a misclassification, as this is North Korean. But probably the American flag, I would guess, could have confused it. Misclassification here. This one, it's saying guessed American was Japanese. This is clearly kind of the opposite of the other one, as this was a correct classification, but for some reason it seems that we have this inside of our Japanese validation set or something. Just a misclassification again here. Similar here. Same. This isn't Chinese or Japanese, so it needs to be probably put to American or removed. And that's just a misclassification. Okay, so we're gonna bring in the widgets now to help kind of clean the data set up. So we'll run the image classifier cleaner, and it'll give us some results like this that will move through and for each category and either delete it or reclassify the image. And then we'll run this code here to actually perform that action. Okay, now we're going to go ahead and run a new model. And still we're not going to use any augmentation transform, since I just don't think they're going to have much of a benefit with this context of how we're kind of looking at something artistic. And I think that shines more in kind of a photographic environment. Just seeing the data here, we can see there are sort of some funky things showing up, like some stuff showing up in the context of a room or a wall, which isn't really ideal, but we'll leave it alone for now. And then just a little peek into lesson 3, we're going to use Tim to get the convex models, so we can play with a little more than just what FastAI comes with out of the box. Okay, so we're going to go ahead and train our new model now, and we're going to use convex nano to do that. And you can see that after cleaning up just a bit of the data and using that different model, we're able to get a pretty significant decrease in the error rate from, I think, 0.46 to 0.25 or something. And we'll take another look at our confusion matrix here. And we can see we're getting like a way better defined line kind of diagonally now. It doesn't seem like there's more than two or three misclassifications, which is great. That's significantly better and makes it much more usable. Okay, and then here's kind of the main difference between my code and what's shown in the course, is the way that I'm exporting and importing the models for inference. Instead of using this exporting the whole learner as a pickle file, we're going to export just the model weights and vocabulary. And the reason for that is just to get a much more platform agnostic form of the model running. I wasn't able to ever get this to import correctly when I was doing it on a Windows computer. Since as we're doing it here in Kaggle, it comes out with like Linux Ubuntu paths that, I tried to kind of put patches over, but it never resulted in being able to run. It just got me more errors down the line. So we'll go ahead and save the model weights and the vocabulary. They'll show up over here, and then you can download them. All right, and I'll see you in VS Code for the next part. Okay, we're in VS Code now. I'm not going to cover too much of how to set up an environment. I'm assuming if you're watching this section that you are comfortable with that already, but if you're not, then all you need to do is just install VS Code and learn to install Conda and just activate the environment. Shouldn't take too long at all. But I'm not going to go into those for this video. So here are our imports. We bring in FastAI, pandas, which we're just going to be using as a table, is basically all. Tim, which is our other image models, and pickle to export the files that we, or to import the files that we exported from Kaggle. Okay, that's the first thing we're going to do is load the vocabulary, which is just the list of classes that we're used to train our class. And the next thing we're going to need is the ImageNet normalization stats. And I won't go way too far into what these are, but just think of them as some values that we're going to use to sort of make sure that our model sees all the images through the same lens. And we're going to need an image to do inference on. And so you can see here I've just made a folder for the lesson, an images folder of images that we'll use to test, and the model weights, this Python file, and the vocabulary. Okay, and so this is sort of the main thing to understand when you're loading the model this way, is that you need to basically create an empty data loader so that we can make the learner and then load our weights from training before into it. So we're basically going to make, just an empty data loader. So here we're going to use the pandas data frame to just make a table, and we're going to borrow the test image's name so that we have a valid image name that doesn't error out when we're doing this. And then we're going to create an image data loader from the data frame, and we'll make sure that it matches the original model transform for the image size. And we will pass that normalization values that we got earlier in, and we will not be using any validation set since we're not training. And the idea here is just to make an empty data loader that has a matching shape and labels of the original model. Okay, then we'll go ahead and create the learner. With no pre-training, we'll go ahead and get the weights and then load them. And then we are ready to do some inference. So right here, we'll just be getting the prediction out. And then this will give us the predicted label, the probability, and the probability. So let's go ahead and give it a try. Maybe throw a new one in here. Oh, so it seems to have misclassified that one as Chinese. It's kind of mediocre confidence, so we'll try a couple others out while we're here. See if something wrong has happened with the inference, or if it's just kind of our model's error area. So we'll do a Russian one. And yeah, it did correctly identify that one as Russian. Pretty high probability as well. Okay, so that's how you bring the model weights and vocabulary in and use them in a Windows environment rather than on something that's going to be friendly with the Linux pickle file. Alright, so the last part is I just want to look at some of the reasons why it's having so much confusion with the Japanese items in the dataset. Okay, so we're here in the in the search results for Japanese propaganda posters, trying to understand why our model's struggling in that area. And just looking at a few of the top items here, it's pretty easy to see that we're getting a fair amount of results that are actually American propaganda posters. Kind of like targeted at or antagonizing Japanese people. We can tell from the characters, of course, and from the racist depictions of Japanese people. And yeah, I'd say it's a pretty good bit of it that's happening in this search result. Probably like 10 to 20% of the results are that rather than actual propaganda posters from Japan. And just for another example, we'll look at some of the Indian propaganda posters. And I don't understand as much of the history here, but I do know that there are many ties from England to India, and so a lot of these are more like like stuff where maybe it's like English propaganda that's like about India or something more. And it seems that India too just doesn't quite have doesn't quite use the propaganda poster as much as some of the other countries we've looked at. So the results are a little less consistent here as well. And so, yeah, this is just something to understand as you use DuckDuckGo or something like that to create your data set, is to ask yourself kind of what biases are going to show up in it. And we could hypothesize a lot of reasons why we're getting results that aren't quite what we're looking for here. But I think generally the reason that we're getting results like this is because search engines operate on like popularity is like sometimes more important than accuracy, right? So I think sometimes just the insanity of some of these Japanese ones might be like, has led to more clicks basically for a search containing these words, and that's why we're seeing them rather than the thing we actually searched for. So this is why it helps a lot to do this initially, to take a look at what kind of search results you're getting, so you might understand what problems you're going to run into before you're just banging your head against the wall since your error rate sucks. Now, this is kind of where the book goes into the ethical stuff, and I definitely won't pretend that I understand all of the ethics behind deep learning and putting it into practice, but I think it's a great time to consult your personal philosophies and ask yourself, what type of a person you want to be as you're bringing deep learning into the world. We have now a function approximator that can approximate any function, and are you going to use that to help and empower people, or make things that help hold them down? It's up to you, and I can't tell you what the right answers will be, but I think right now is a great time to think about what ethics are going to mean for you in deep learning. So I hope this video has been useful to you guys. If it is, maybe I'll make some more further into the course if I'm seeing stuff that maybe needs just a tiny update. And yeah, please let me know if you guys have any other thoughts or anything I got wrong in the comments. And thank you for watching.